Hello, everybody. I hope you can hear us. I hope you can see us. Good evening, good morning, wherever you are. It's time to talk a little bit about art. It's a little shiny, but we'll see more art in this session today. We all want to be good modelers. We want to build really, really nice models. And there is a lot more to it than just methods and technology and learning to program or dragging over these blocks. And this is what we want to chat about tonight in a relaxed way. Sit back, have a glass of wine, let's put up the fireplace. I still remember many years ago when Stefan Bengtsson, the first gentleman that joins us tonight, introduced me to this concept of the art of simulation modeling, that it is actually art. He literally told me, Ben, simulation modeling is like painting a dynamic picture of reality. And this is stuck with me up till today, this quote. And on the other hand, I still remember first understanding the vision of Andrei Borshchev, the other gentleman on the panel tonight, the CEO of AnyLogic, first truly understanding his vision of we shouldn't have simulation tools that let us build discrete event models or agent-based models or system dynamics models. He basically said, we need a tool that just lets us solve problems. And that is the vision of AnyLogic. And when it first clicked to me what he meant by that, that we paint models and we use different brushes or pens or whatever to get the problem, solve the problem, that was really, really impactful. So I'm really, really glad we have these two gentlemen today. And what we want to do is have a relaxed chat about these philosophical topics that we just continuously think about. So let me move the stage or make a little bit of space. Let's first hear a little bit from our panelists about themselves. What I want to know, and let's start with Andrei, is how did you get into the world of simulation at all? And how did you then start AnyLogic? Because I think that's going to be quite interesting to many of our listeners.
Thank you, Ben. Thank you for the introduction. I'll try to be short. So my background is applied mathematics and computer science. And in the beginning, I was doing a lot of research at the university and later on with Hewlett-Packard Labs in Bristol, Great Britain. And that was about how can we formally verify programs, prove something about them. And I was deeply into that very, very kind of academic topic. And as a side effect of that, I realized, okay, there's a whole other area where we cannot probably prove that formally things are correct, but we can test them by simulating things. So I'm coming from this computer science modeling and simulation of computer systems. And then gradually, as we were working with our early adopters in early 2000s, we migrated towards modeling and simulating kind of business systems. And that is why AnyLogic, and that is why AnyLogic has some languages that were not typical in the area. So roughly, that's it about myself. And
how did you start out actual AnyLogic? When did you have that spark of these existing tools just don't cut it anymore?
Let's say 1998. We wanted to do, there was no business idea by then, and we were just programming some abstract general purpose modeling and simulation tool, which, as we were later told, was the first, let's say, kind of commercially looking agent-based modeling environment. Because it did have all these object-oriented structure and objects, which are essentially agents, connections, and language of state charts.
Very cool. So let's bring us the second panelist, Stefan. Hello. Tell us a little bit about yourself. How was your journey into simulation? And then how did you first hear about AnyLogic and have that, that's what I need kind of spark.
Okay, thanks, Benjamin, and thanks for having me here. As Andrei explained, also I have an academic background in applied mathematics, I guess you could say, tilting towards operations research, system theory, and so on once upon a time. And when I, 1988, took my first step into the working world, getting a job as a consultant, I got to a little department working with technical calculations. And one of the areas we did technical calculations for was operations research. And the first day, I think my manager told me that all these fancy mathematics that you have studied at your Institute of Technology, we have experienced when we work with customers that it doesn't really suffice. We need simulation instead. So when we started to address challenges in the real world, in the Swedish industry, in the Swedish transport sector, we did it with the help of simulation. And I was lucky enough to start working with a modeling platform of Simula. And Simula is by many considered to be the first object-oriented language. The language that's the mother of Java, the mother of Smalltalk, the mother of C++, and so on. So that was really the platform that formed my way of thinking about simulation. I learned that you can do anything with simulation because I had this whole programming language, and I even had a class called Demos, Discrete Event Modeling on Simula, written by a Professor Graham Birthwhistle. He had constructed this class, which even enhanced the possibilities to model with Simula. So I worked with that for 5 years. Then I left, didn't work any longer as a consultant with simulation, and moved on to work in various more leadership and management roles. And also studied management and business administration. And roughly 10, 12 years after that, I had reasons to start to look at simulation again. And I was a bit curious, can I use Simula? Can I use Demos? No, I couldn't. So I started to review what did the world market look like. And I Googled and looked at all the various names I had kind of remembered from the old times when it came to platforms and programs. And I didn't really feel that any of those could match what I could do with Simula Demos. Then I found a new platform that I hadn't heard about since I hadn't worked with simulation for 10, 12 years. And that was the platform of AnyLogic. And given my demand list, it was really the only platform that matched what I wanted to have as a platform. I wanted the ability to work with a sophisticated object-oriented language, and it was based on Java. I wanted a possibility to work with both agent-based and discrete event modeling. And in addition to that, of course, you could work with time continuous modeling in AnyLogic through system dynamic or dynamic systems. Because a bit of a fun fact is that I would claim that Simula and Demos was really more agent-based modeling than discrete event modeling, or rather, it was a fusion of discrete event modeling and agent-based modeling, but we didn't use the name agent-based modeling. So in a way, Simula Demos had already agent-based modeling, but Simula Demos was not successful on the market, so it kind of died out. And then agent-based modeling in commercial form was reborn in a way, and more sophisticated through AnyLogic.
Cool.
That's
all
at
right.
least my take on it, rightly or wrongly so. So that was my background, and that's how I really got into touch with AnyLogic once upon a time. That was 2005 when I found AnyLogic.
we have lots and lots of people joining, which is great. So feel free to chat in the chat. Also use the chat to ask questions. We'll have time at the end, or maybe if I see a super interesting critical question, we'll answer that live in the middle of the call as well. So make use of that. Welcome everybody. I've seen New Zealand, I see Tunisia, I see Sweden, I see we're almost global, which is fantastic.
I saw Brazil and South Africa as well, and Turkey. So yeah.
Very good. Very good. Alrighty. So when I started out, I started out building simulation models. They always looked like this, like paint by numbers. Very simple models. Somebody basically gave me instructions. I followed step-by-step tutorials, and then kind of they did a job. They don't look too bad once you draw on them, but it's not real art. I mean, this is a picture of that my wife did. It's not a picture of my wife, but by my wife. She's a real artist in the family. And of course, you need a lot more skill than just dragging and dropping a lot of things. So my first real question is, why? Why do you think is simulation modeling? Why does it have this artful side or this non-specific, non-technological side? Where's this coming from? What do you think?
All right, I can probably take that question. And so I think this metaphor that Ben came across and used in his invitation to this webinar is just brilliant, because both what artists essentially do, they represent reality, but they represent reality in their own way, processed through their kind of brain and through their understanding of what reality is and what they want to sort of highlight there, right? So any painting is an abstraction, of course, and it is a representation of reality. And we simulation modelers actually do exact same thing, right? So we look at real system. We have the problem in mind that we're told to solve, and we build our model, which is also an abstraction always and a representation of reality. And so that's very, very natural. And of course, there's difference, because painting is like this one, for example, or the other one over there. These are, by the way, my paintings. And if you guys do some work, you can figure out what's my Instagram. So you're welcome to subscribe. But anyway, as simulation modelers, we do dynamic models, of course. So we make this static stuff, progress through time and move, but essentially we're doing same thing. I would suggest to, as long as we're talking about art, and in the context of this webinar, the opposite of art is technology. Why don't we try to sort of agree on terms? Ben, would you mind me showing the slide I prepared? Because I have some kind of couple fun slides for you guys.
Go for it. Before you do, though, let me just briefly say we have a chat where you can say hi and chat to each other, and we have a separate Q&A section where you can actually ask questions. So use that, because then I can flag them and I can see them in a ordered way, and we can answer them structured. Stefan, you have something as well?
Yes, after Andrei's slides, I would be happy to also share some reflections related to this art concept.
Cool. All right. So you guys should be seeing the empty slide now. Can you see well, Ben, yep. Stefan? Yes.
All good.
All right. So we have art up there and technology down there. Now, roughly, can we agree on that technology is something we can learn? Art is something which is hard to learn. Is something that has to be in there. Would that be correct to say in the context of this talk?
Agreed.
Agreed. Cool. And now So technology, in our case, in the case of simulation modeling, you should be able to talk to subject matter experts. Of course, you should know what you're modeling and why, of course. Second, you need to know your tools, and you should follow a certain process, which we will not dive into. Now, the opposite of that is kind of create. By creating, we probably can understand making non-obvious decisions, follow your intuition. At the same time, don't be afraid to think counterintuitively. And of course, try, experiment, and be ready to discard your work. In addition, if we talk about simulation modeling, same thing. You should know the stuff, right? You should know the tools that you have, and you should follow the process. So art is a lot more, I would say. Now, and this is something I suggest you guys to think about. Can I suggest this? So detailed models are easier in a way to put together than abstract models.
That's really interesting. It's probably not that simple to say it like that. I think if I always tell the story where I started modeling a huge aluminum factory, and the very first model version was literally 5 blocks from the AnyLogic discrete event library. That was the entire factory. That was highly abstract, but also quite easy to do. It just meant this mental leap of I abstract everything into these couple of blocks, and I don't care about anything else. But I understand your point. In general, painting an abstract model, an abstract picture, takes a lot more experience and skill than just building very detailed models. And especially we see in the community, the beginners that reach out with questions about their models, the models are always far too detailed and far too intricate. And that's really the root cause of all the troubles that they're having. What do you think, Stefan?
Yes, I agree in the sense that, but with experience, you learn what not to model. And there is a tendency, probably when you're less experienced, to go into, therefore, too many details. But perhaps easy. I would say that detailed models are easier in one sense, but can become more complex in another sense. So it's not black or white, I would say. There are challenges with both ends of this scale, but with seniority and with experience, yes, you tend to move up to more abstract models and be better and better of dropping some of the details.
Cool. And then
which is also like a similarity to real art, right? I keep on talking, like Impressionists recently went to this museum, and they literally, the more experience they got, the faster they were painting those pictures, and sometimes it's just a couple of strokes and it's like a masterpiece.
Cool.
But go on.
And then, Ben, I wanted to expand basically on what you just talked about, and a couple more. So as we all agree, simulation modeling is a sort of the art of abstraction. So I would say that our type of modeling started as a highly abstract art around what was it, like 70 years ago already. And look at this. These are rock paintings, right, from Australia and India, done by prehistoric men. And did they want to be more realistic and more precise, more detailed? Probably yes, but they didn't have tools. They were very limited in terms of tools. And Same were our type of modelers in like 60s when they were using tools like GPSS, and what you were seeing on the screen are GPSS script and then GPSS process diagrams. So I would say that these guys had to be abstract because they were using primitive tools and not really well-developed technologies. And I'll just do one more. And similarly, around the same time, this method was invented, and this is, of course, system dynamics. Very, very different. Also primitive in terms of language, very minimalistic. However, look at that. Does it represent reality one-to-one? Not at all. This is, by the way, the best diffusion model, and this is about adoption of technology or product, or about selling new things. And okay, so we probably can understand what in the real world potential adopters are, but okay, what is ad effectiveness? What does it correspond to? What is adoption from word of mouth? So why would you introduce all these variables over there? So I'd say in general about system dynamics that, okay, these models are really minimalistic, highly abstract, but not primitive at all. They're probably the hardest models to do, and they're crafted by I would call them a sect of really high-end modelers, and they're all snobs. They kind of their work in a kind of closed community, and these are true artists. So, okay, what on the left-hand side, what can we kind of put there from the art world? I would say this. This is famous Picasso painting of a bull. Now,
I've never seen that before.
Yeah, did Picasso know how to paint a bull? Well, of course he did. He of course could do it better than anyone else, right? But he crafted this in 46, right? And it's super minimalistic. It's super cool. Is it hard to paint like that? Not at all. Not at all. And it's high abstraction level. So I will probably stop here, guys. And yeah, we'll switch to our videos.
That was really cool, Andrei. Really nice thinking there. What did you want to add, Stefan?
A few more reflections really related to whether a simulation is an art or not, and I definitely say yes, of course. Perhaps we should throw a few more words into the mix, and one word would be craft. I had a lunch discussion with a senior colleague a few days ago, and he said, "Isn't modeling a craft rather than an art?" And I would say both. Craft and art kind of goes into each other. And I think one key and a reason why we should think of it as an art is that an art needs an artist. A craft needs a craftsman. If we compare that with technology or with science, it's not at all as obvious that you need an individual with a talent in the mix to be successful. And that's really, I mean, you can't put AnyLogic or any other simulation tool into the hands of someone who does not have the talent to build models with that tool. And that implies, I think, that if we don't think of it as an art, we miss the dimension that this is something where an individual with a talent, with a skill needs to be involved to be able to reach a painting that's worthwhile to look at. So I think the dimension of an artist is an important reason for thinking of this as an art rather than a science or rather than a technology. And I usually say, is it an art or is it a science? Andrei said, is it an art or is it a technology? And had that scale instead. We can use both scales. A reason why it's not is a science, I would say, is that with science, we kind of automatically think about the science gives us the truth. The science gives us certainty. Simulation is for all these issues in the real world when there is no truth, when we struggle with uncertainties, where we struggle with different dimensions that kind of cannot be fulfilled all at the same time. And that implies that we can't see it as a science, because a science is more black and white, and simulation is about the grayscales in real life that we only can address with competence like simulation. So I think that there are a number of reasons to think about this as an art. It's creative, as Andrei said, but also the fact that we need an artist, I think is quite important.
I would say both of you count as artists, but let's move one step further. Now I haven't talked about that there is a dimension of art to it. How do you actually apply that when you build models? Or maybe for Andrei, how do you apply it when you actually build a tool for us to build models? So how does the AnyLogic company maybe code in an artful way, structure AnyLogic in an artful way? And then for Stefan, how do you build models and apply your art? Mm-hmm. Let's start with Andrei.
Right. So I think that's modeling paradigms that did exist when we sort of entered the market. They were two disconnected communities, and one of them was discrete event, arena, etc. And then the other one was system dynamics, different conference, different people. And I'm coming from like the third community, which is, computer science, object-oriented modeling, etc. So, and when we look at a certain problem, this discrete event obviously suggests that we do view it as a process. Right, process, which is obviously a sequence of operations performed over entities, and we have certain resources involved, and this is what all discrete event modeling is about, right? But it's not always the case. That's the thing, because sometimes you look at the system or a problem with a system, and you don't see any process there. You see there's something else, right? And then you think, okay, how do I actually represent that, right? I need something different, like a process flowcharts just doesn't work for me. I need something else, and that something else could be state charts, for example, and also space. I have another slide on that, but the thing is that space in our world are not limited to 2D and 3D. There are other spaces that can be used and are used in simulation modeling, but we probably can return to that later on.
Yeah, that conceptual decision, I have this system and I have these tools now. I maybe have AnyLogic open with all the libraries and blocks and stuff. And how do I do this now? I think this is a real big challenge. This is what we advanced modelers with artistic experience, let's say, kind of naturally do and informally know. But it's very hard for beginners to make those decisions. So Stefan, how did you learn to make those decisions? And what would you say to beginners? How should they grasp or do this best? Learn modeling. What advice would you give to yourself as a younger modeler?
Good question. In a way, I also struggled in the beginning with AnyLogic, since I was formed by Simula Demos. And in Simula Demos, I had the freedom to, as I tried to describe, to merge more agent-based thinking with more discrete event thinking. That division was not really made in Simula. We worked with objects called classes or called entities, and we could make those entities passive, active, whatever we liked, and combine and make them interact in various ways. So this whole concept of having various paradigms, in AnyLogic, you can play around with these various paradigms in the various libraries, but still having this division was new to me. So therefore, I had to relearn how to think what I knew had to be done by starting to understand how to combine these libraries in AnyLogic. But I had the possibility to do that with AnyLogic. I wouldn't have had that possibility with other tools. So what would the advice be to new? It is hard. First advice is that struggling with a new platform, a new tool, a new environment, even if you have experience before, is always hard, because you have to learn a new way to think, a new way to structure the logic you have in your head. I always find that going through the tutorials, which I think are excellent in AnyLogic, is the best way to get up to speed, at least with some of the basics. Go through all the tutorials just to get the feel of it, and repeat some stuff and learn some new stuff. I probably would advise to start with the discrete event modeling end, the process modeling end, rather than agent-based modeling if you are a newcomer. And then when you get fairly familiar with that, okay, start to try to think more agent-based as you get more experienced.
It's probably also one of the gentlemen, I think it was René in the chat, just said, with all the libraries in AnyLogic, once you understand one of them, suddenly you have the tendency, I solve all my problems with this one library, like the discrete event one. So the advice I would give is also to try to rebuild your model with a different approach, with a different system. I remember when I learned AnyLogic, the very early days, I had a training course as well with Dave Buxton back in the day, and we built the SIR model, susceptible, infected, recovered, the classical system dynamics model of how COVID spreads or disease spreads through the population. And then we rebuilt this as an agent-based approach. And it opened so many neurons, so many synapses in my brain, just the insight that you can actually paint the same problem in very, very different ways. I could paint this abstractly, I could paint this realistically, I could stitch it or whatever. So my advice is try to use all the things in AnyLogic to get more experience. Yes, Stefan.
Yes. Yeah, and that's also partly the reason why I said going through all the tutorials is a good start, because then you get a taste of most of the libraries, and you get the chance to see that you can build different types of models.
Gentlemen, let me entertain you a little bit more, and our audience, of course, because you started mentioning agent-based, etc. And agent-based, as we all know, appeared on the, let's say, commercial scene later than other approaches. So what I want to do, I want to share another slide.
By the way,
we were
tons of questions, which is great.
Yeah,
pushing the
cool.
questions. I noticed
Yeah.
them and we'll
Yeah.
get those.
So we were here, and that was, as I mentioned, like 70 years ago. Now, what was the evolution of these tools over time? So over time, so-called discrete event tools moved towards more and more detailed representation of reality. So they were getting more and more libraries, more and more objects to kind of physically match, not physical, okay, let's say matching the exact objects in our real world, like racks, forklift trucks, cranes, machines, conveyors, roads, rail cars, etc., etc. And of course, they did add animation. So, okay, continuing okay, not our, but Ben's metaphor, we actually moved into that direction in art. And these are the two beautiful paintings, one by Charles Schiller and the other one by Edward Ruscha. And this is what can be called modern/contemporary art. So it's, let's say, second half, or let's say last 2/3 of the 20th century and beginning of 23rd century. So if we draw this chart where we have detailed at the bottom and at the top, we have and system dynamics, which did not change in terms of tools and technologies over time at all. They're still using same paradigm, same set of minimalistic set of concepts, and actually I would say system dynamics denies evolution of that. On the other hand, so-called discrete events, which I would probably call rather kind of process modeling, started with GPSS scripts and moved all the way to contemporary hyper-realistic models, also known as management porn, if you will. Now, that you can do with these days tools. You can make your model be really, really super cool, realistic, represents like every, I don't know, scratch or stain on every box in the warehouse. Now, it's still a question whether we need that to solve problems. I'm not questioning there is a demand for that. Of course, there is demand for that. Now, and so to me, useful range of discrete event models is somewhere here, right? So, and I want you guys to agree or disagree with me that my point is that these days, useful models, although you can do them very detailed, technology allows you to do that, but they don't need to. And not all of them need to. So, would you guys be willing to kind of, comment on that?
Yeah, I would.
Yep.
So I agree, but I would go further. I would actually say most models should not use that hyper-realistic approach, and it's a constant fight against management, against decision makers who are influenced by these shiny videos and NVIDIA Omniverse and really, really super advanced simulations, and they immediately think from the nice animation, we're going to have a warehouse or a factory where each forklift's wheels traction is modeled in a physical way, which is crazy. And fighting that back is so hard to basically explain. The more detail we add into our models, the less useful they will be. And the less detail we have, the more useful they are. And we should actually start from a problem perspective. What's the problem that you want to solve? And so often I get managers who just want the hyper-realistic digital twin that can do anything and models everything, but this results in you not being able to do anything. It's analysis paralysis in the end and combinatorial explosion. So we should keep things simple. What do you think, Stefan?
Yes, we definitely as a whole should keep things as simple as possible, but you still can have a model where you, in average, I mean, a model is really consists of various objects or modules, and it might make sense in a more abstract model to have parts of the model that are quite detailed for some reason, because that might be a part of specific importance giving the stakeholders of this specific issue. And then it might be a way to build confidence to have a part of a model being lower down on this scale, even though the average of the model or the whole model is on a higher abstraction level. So I think it's a bit dangerous to discuss a whole model to be specific level, because a model consists of so many different parts, and sometimes there are reasons to have varying abstraction levels for varying parts of the model.
Absolutely. It's another similarity with art, right? If we look at most art, the black areas are very, very high abstraction level. She didn't paint anything there. But the thing that is important for the purpose of this picture, like these bubbles, she put a lot of detail in those. Yes. And that's what you mean, right? That's how we should build models. And one step further, we should even enable you to easily replace these things. Maybe I just want a high level of detail bubble, and other users might want a super, super realistic bubble. In art, you can't do that. With simulation models, you can.
Yes. So basically, what we're doing, we're mapping reality that we know out of talking to someone to modeling to the canvas, let's say, okay? Because canvas can be that kind of canvas, or it can be canvas in AnyLogic. Now, what helps you? How do we do it? We use languages, right? And I'd say that there's no big progress in terms of modeling languages since, let's say, since AnyLogic introduced state charts and agent-based modeling in early 2000s. So we still have, in terms of languages, we still have process flow charts. We still have, in AnyLogic, you have state charts, and we have system dynamics to describe some, not really continuous dynamics, I would say highly abstract stuff, but it is continuous dynamics mathematically. So I wanted to your opinion on what do you think? Has there been any progress? Or maybe you anticipate progress?
I don't even think maybe we don't need more tools. If we go back to the art world, I mean, artists have been painting with brushes for centuries, right? And they still come up with beautiful paintings. So I think with each technology, there is a plateau where you reach the best tools. And state charts and process flow blocks and system dynamics, these seem to be highly polished end results. We may see completely new paradigms popping up. I don't see any really, but it might happen, whatever LLMs comes up within the next couple of years. But I'd say we should focus on building better models with the mature tools that we have. I don't see any need for much more. What do you think, Stefan? It would be good to have new tools, though. Not saying that.
I agree, because I know that in 1988 to 1993, I could do most of the stuff with Simula demos. Then I have gotten a number of additional features with AnyLogic pedestrian modeling. And the most valuable feature I have found in AnyLogic is the ability to visualize the logic as such. I could never do that with a programming language. I couldn't visualize the logic. I can do that with AnyLogic. And I think this ability that you find in AnyLogic is quite often forgotten. Animation is discussed, but not the visualization of the logic as such. And you need it. You will have numerous situations where you never will be able to convince the stakeholders of the quality of the results of a simulation if you can't show the logic that has generated these results. I kind of found that out when I started to work in the healthcare industry with modeling. I mean, educated medical doctors would never accept the results, even though they are perfectly correct, if they didn't see that their reality was in some sense captured by the logic of the model. So for some stakeholders, for some specific issues and challenges, you need this possibility to visualize the logic. And you can do that with AnyLogic. I couldn't do that with Simula demos once upon a time. But the logic as such, I could build more or less most things with Simula demos. So my reflection in 2005, when I returned and started to look at simulation, was that the progress had been negative. Then I found AnyLogic and saw, okay, here we have an exception. Therefore I got interested in AnyLogic. But no, I don't think we need more than we already have.
I would actually,
of course,
I would go one step further. I agree with you, Stefan, and throw it back to Andrei. We kind of agree we don't need more paradigms or tools. If I open AnyLogic, there's so many blocks and so many libraries and so many great tools. I think what we should focus more on is how can we make more artists? How can we make more more experienced modelers? So how can AnyLogic help us build better models, especially for beginners and medium users? Because at the moment, it's not criticism, but my observation is with these libraries, you are implicitly encouraged to drag and drop stuff and make it snap together, which is not always the best way of building models. And I've got a couple of ideas what could be done, but I'd be curious to hear, Andrei, how do you think, how can you make the modeler's learning journey better and easier?
Right. One of the things we are doing, and I think it is in that direction. It's a very simple thing, and however, it is our major investment during the last 7 years, I think. And that is simplify access to AnyLogic. So right now, if you have an account at AnyLogic Cloud, you can actually try out the new online version of AnyLogic, which is there, and that's the simple fact that it's always, you know, at your hands. You don't need to install anything. It already works for let's say easy access, bigger audience, etc. Of course, it does not solve the problem of, you know, educating people. I mean, how do you teach AnyLogic? And that, I think, is probably the main barrier towards more simulation models being built around here, because you can learn programming, you can learn Python or Java. It's not a big deal, right? There are, like, you know, tens, if not hundreds of million people can easily, or not easily, but still can learn that. There are much fewer simulation modelers. And that is, of course, because our type of simulation modeling suggests that there's a kind of, say, fourth dimension, which is time, right? And how do you deal with things changing in time? And it does require certain kind of twists in your brain that you should make. So I'm probably not the right person to ask how. I'd rather, you know, teachers, like professors, would answer that question. So maybe, okay, Stefan, what do you think?
I would say that perhaps the most obvious reason I think that simulation is not used to the extent that it could be used, I think it's more cultural, it's more in people's head. I think it's about this focus on data. I think that, and in my mind, it's really that simulation in a sense has sometimes been kidnapped by the academic thinking. I'm quite angry at concepts like validation and verification. Of course, when you have the luxury to validate and verify, please do so. But there are tons and tons of issues and challenges out there in real life where this is no option. Because we are struggling with so large uncertainties that this is not really anything to consider. And what happens, given the way many think, is that, okay, then we can't simulate because we don't have data. But I would say, okay, because we don't have data, but we still have a challenge, we have more reason to simulate. We have more reason to model, because simulation is 0% about data, is 100% about describing and painting a picture of a logic. And I think this focus on data really causes more than 99% of all the challenges that should be addressed with simulation not to be addressed. Because
that's a fair point.
A lot of people say, we don't have data, therefore we can't simulate. And that is, for me, probably the largest hurdle. And it's not in the technology end, I think. It's in the mind end, how people think about this competence. If we could crack that nut, then we would open up a box of understanding that this is a tool to draw either abstract, either sloppy or more detailed, a picture of how we think about the specific situation. Then we might open up for more to use simulation. So expressed in any way, I think that's the biggest hurdle, how we think about simulation.
I don't actually think it's the biggest hurdle, though. I'll get to you, Andrei, in 1 second.
Yeah,
I think it's a big hurdle, but I would actually think what Andrei mentioned before is a bigger hurdle. You're basically saying now it's easier to start building simulation models because we have it in the cloud. And I would say that's a nice, good step in the right direction, but there is more that could be done. And that takes us to most of the questions in the chat, actually. Most of the questions are basically AI. So one of the ideas that I'm having in terms of how could modeling become more widespread is some sort of using AI embedded into the tool. Simple example, many beginners build models with dozens of these blocks. The simplest implementation of this could be a little clippy in AnyLogic saying, hey, you just dragged in the 20th block of the process library. Are you sure? Are you sure this is a good idea? Here's a link to a blog post that explains why you probably don't want to build this spaghetti model or something like that. And then you could take it obviously much, much further with native LLM support or whatever. So I'd be curious, Andrei, first of all, I'll say the point you wanted to say and then maybe address what you think.
Yeah, I will probably come back a little bit to what Stefan mentioned, because Stefan mentioned data. Now, I recently saw somebody else's good slide saying that, okay, if you connect data to visualization, you get, you can call it a digital twin, but it's kind of informative digital twin. Or if we return to our previous discussion, is depending on how it's used, but in most cases it will be just management port. However, if you add the simulation component in there, right, you convert the whole thing, data, simulation, and visualization, into a predictive digital twin, which can be really used in decision support systems. So that was my sort of comment on, or addition to what Stefan did mention before. Now, what's the plan? Because we have 5 minutes left.
Talk a little bit about the future of simulation and AI in the future of simulation. I think people are very curious to hear that, what your thoughts are, and Stefan as well.
All right. Okay. Obvious things. I mean, those who did follow our blog and everything know that simulation is a natural environment to train and test AI, to generate synthetic data. And there's a lot of kind of buzz about another buzzword these days is synthetic data. And if you look at what we are all doing with our simulations, we do generate synthetic data, right? And we can do it in any way we want. It can be massive. It can be detailed, less detailed, et cetera, et cetera. So we can do a lot in that direction. And of course, there's kind of this usage of, this way of connecting AI to simulation. Now, there's the other one that Ben just mentioned, is having AI helping you create simulation models. And recently, I had a pretty good chat with ChatGPT, asking ChatGPT, okay, do you think AI could ever be a replacement to simulation tools? And the answer was pretty honest. The answer was, no, I cannot be a replacement to simulation tools unless I have a simulation tool somewhere in my backyard. You see? And it's interesting. Okay, ask ChatGPT to multiply two 5-digit numbers. How would it do it? It will simply use arithmetics, right? A calculator. It will not do it based on his, experience. Same thing with simulation. To predict things, to tell you how things unfold in time, it has to build internally a simulation model, execute it, and deliver you the results. So at the moment, usage of AI is assisting you with simulation, let's say conceptualizing the problem, one thing, helping you with scripting is the other thing, and helping you with interpreting the simulation results. This is where AI is really good at, connecting dots, discovering things in simulation outputs, etc. So that is probably my view on how AI can be used, coupled with simulation.
Stefan, last words from you. What do you think is the future for us modelers in a world of AI?
Oh, I'm not the best person to have a view related to AI, but more generally, I'm always a bit skeptical when we try to simplify something too far. And the reason for that is that there might be something lost in that process. And I mean, to use simulation in the correct way is a fantastic competence and tool to take better decisions for complexer and less complex issues. It's also a fantastic tool to visualize and get better understanding, but it also is a fantastic way to make the artist, the modeler, more talented during the process of modeling. And that part is often forgotten because the education you get by building models is hard to get any other way. You learn to think in terms of processes. You learn to understand a system. You learn a whole lot of stuff And the simulation project as such also makes everyone involved learn a lot about the challenges. So, I mean, it's quite regular that in a simulation project, you might have made 70% of the conclusions before you start to simulate, because you have learned so much during the process of building the model. And that implies that if we at least too much try to simplify this process, I see dangers with that. But again, I'm not the best person to have a view when it comes to AI as such.
Well, thanks a lot.
That was more general reflections.
Now, kind of coming to the end of this session, I hope you all enjoyed it a lot. Most of the questions, there were, I think, roughly a third was about AI, which I hope we addressed. Another third, or maybe a half, was questions: is it possible to do X with AnyLogic? To which we can simply answer yes, hence the tool name. So yes, you can do anything with AnyLogic. There's basically nothing you cannot do, so rest assured. And the other thing I wanted to say is, before we started this call, we already said, hey, it would be nice to have more of these kind of sessions. So if you agree with that, then let us know on LinkedIn, or tell Andrei, or support@anylogic.com or whatever. Just let us know. I think we will have more of these, right, Andrei? I would very much enjoy that. I really just enjoy chatting.
Let's do it. Let's do it, Ben. I'm in.
There are many, many other people with really, really interesting thoughts out there. So yeah, that'll be really, really nice. Otherwise, thanks a lot all for the attention, and thanks to Andrei and Stefan, and thanks to AnyLogic for having us and giving us the platform. Much appreciated.
Thank you, Ben. Thank you, Stefan. Thanks, everybody.
Thank you, Andrei, Benjamin, and everybody.
Bye.